The box folding prototype consists of two main parts: the pick and place, which picks up the flat boxes, and a folding jig known as the Crucible, which does the folding. All the actuators used are controlled via a PLC mounted on the outside of the frame. The first step is to extend the pick and place arm onto the raw stock material, and then turn on the vacuum pump. The pick and place is then retracted. A mechanism called the push arm is then extended, which takes the pick and place over to the Crucible. The pick and place is again extended, pushing the box through the Crucible. The pick and place is then retracted so that the last folds can be made. The B' folds are then made by a roller mechanism. The roller mechanism is retracted, and at this point the final tuck using the claw mechanism was supposed to occur. For demonstration purposes, the final fold will be made by hand to show how the last fold would be made. The box tops are retracted and the box drops. In a production machine, the box would drop onto a conveyor. For this senior project, a conveyor system was designed but not implemented because it was not necessary for the proof of concept for the prototype. Here's the box tops from a different angle. The box tops are actuated with a pneumatic double-acting cylinder. The pick and place and push arm features and challenges. The largest part of the prototype is the push arm, a double-acting cylinder that pushes the pick and place from the raw stock material to the Crucible. The pick and place uses a single pneumatic double-acting cylinder with guides to perform the pick operation. Attached to the cylinder is a plate that holds 6 suction cups. Vacuum is provided to the suction cups with a Venturi pump. The Venturi pump and the other pneumatics are actuated with 5 tube valves located on the manifold that is next to the push arm. The major challenge for the pick and place is alignment of the raw stock boxes. Misalignment of the table caused the box to not fold properly when placed into the Crucible, resulting in a box jam. In slow motion, it can be seen the left side of the box fold first without breaking the tab, followed by the right side folding but with the tab breaking. When either tab is not broken, the box will not go into the Crucible. The Crucible features and challenges. The Crucible itself is a feature completely unique compared to other box folding machines. The first fold is created using B-tab breaker bars seen here, which cause the B-tab to break free and fold so that the box can fold into the Crucible jig. After the box is placed into the Crucible and the pick and place is moved out of the way, the B' roller mechanism rolls in to make the B' folds. This has proved challenging as the box side is not rigid enough at the lower fold to provide enough moment to prevent the box side from pushing in, yet the box is too rigid at the B' fold so the B' fold cannot be made. When the B' fold is creased before going to the machine, then the fold can be properly made with the B' mechanism. If the team had more time, a redesign would be made either to hold the side of the box more rigid or crease the B' fold before going into the Crucible. The last folds to be made are called the D and E folds, and they require a tucking motion that was supposed to be provided by the claw. The claw has proved to be one of the most technically challenging aspects of the project due to the fact it has to make several folding motions at once. Although we are unable to get the claw mechanism working with the box, we can show the general motion it was supposed to take. First, the claw was supposed to be moved closer to the box using pneumatic actuators as seen here. Then the claw was to rotate, which would move the flap down. The pneumatic actuators were then pulled back, tucking the flap with the claw and pressing the flap into place. Finally, the actuators were to be extended, the claw rotated back and out of the way, and then the claw moved back into its original position while the box was being released. This tucking motion proved to be very difficult, if not impossible, and with more time, the box folding team would have liked to try using hot glue to hold the flap in place. Some other challenges encountered with the claw was tuning the motors to prevent severe overshoot and oscillatory motion. Here you can see the claw before being fully tuned for operation. The electronics of the box folder. The electronics for the box folder is mounted on a plywood sheet for visibility and ease of access. A production machine would place all the components in an electrical panel box. The components are mounted to the panel using industry standard DIN rail, panduit, and other fasteners. The panel consists of 2 power supplies, a Unitronics PLC, a Unitronics I/O expansion module, and 2 servo controllers for the claw servo motors. Located below the panel is the pneumatic manifold and valves for the Crucible. Currently, the system has manual operation only. Future improvements will require an automatic system that runs with no operator present. Lessons from the project. Although the project could not fully fill the box, the operations that were able to be implemented were within the original project specifications of 2 boxes per minute. We learned from this project how to implement more complex pneumatic and mechanical systems and got hands-on practical experience of choosing actuators. We learned that using a higher safety factor when sizing motors is preferable, and we learned some of the complexities involved in sizing many components at the same time. What you see here is a result of several sizing iterations and several iterations on the prototype. With a few more iterations, we believe we could have gotten this box folded. We'd like to give a special thanks to Certainty for their sponsorship, especially Dan Arata and the mechanics. A big thank you also goes out to Bob Carey for helping us with the electrical.